There was a bit of logic I wanted to, or it's kind of part of logic that I wanted to explain. To do with wire blend modes. So if you have a value and you plug it into a port like that, then it has that symbol there. But if you hold L1, you can see what that means, and that symbol is overwrite. You press L1 and X, it cycles through them. So there's blend, overwrite. Actually, I'll do that. Oh no, that one doesn't work. Let me get a calculator, and yes, it's plugged in there, and because this can have a value in it, there's another one called Modulate. So there's Overwrite, Blend, and Modulate. Overwrite it finds from all the wires coming in, it finds the highest value and sets this to that highest value. So if you have 0.2, then it's setting it at 0.2, and this being equal to or less than 0.2, it will ignore it unless it becomes more than 0.2, and I'll use that one instead. That's actually the way an OR gate works, which is that one. So if I plug those in there, then so when this one becomes more, it becomes the highest number, so then that gets displayed, just like with a blend mode thing. And if you look at that value, that symbol there, it's the same as an OR gate. Now the next one is Modulate. That basically does the same thing, finds the highest value, and then it multiplies whatever value is in here originally, and sets the setting for that value. So if I put that, so out of these it will pick 1, so it'll go 1 times 1 times 2. The actual setting is set to 2, so if you send in 0.5, now it's 2 times 0.5 is 1, and that's how that works. And if you had a second one that was higher, back up to 1, uses the highest of those two, so it's 1 times 2 is 2. And this works for like negative numbers as well, so 2 times minus 1 is 2, and you can always hover over this and see the original value and adjust it as normal. The next one is blend. I'll make this bigger actually. Blend. Now blend is averaging out these values. So if you have 1 and 0, the average of that is half, because it's 0 plus 1, and then you divide it by the number of values, which is 2. So 0 plus 1 is 1, divided by 2 is 0.5, and that's the value that it sets. This is pretty useful for adding stuff up. So if you can add stuff up with a calculator, of course, just using plus. But you can only have 2 values at once. So if I use this instead, I have 1 plus 1 plus 1. That averages out, because it's 3 and there are 3 values, it divides by 3. The average will be 1 again up here. So if you times it by the number of values coming in, such as 3, now you get out of the result, you get the original value again, or the sum of all those, because you're the average divides it by 3, and then you're timesing it by 3, so you get the sum again, like that. So if we can't see. So if I make that one smaller, now it's 2, and we're getting 2 out the other side. And you can have any number of these, as far as I'm aware, as many as you want, so you can do huge summing, a whole list of stuff very easily using one calculator. Another thing to be aware of, though, is that it weights these by how much power they're receiving. So if we put that back to 3, then I turn one of them off, then it's hard to see. So actually, if I make that 0, yeah. So we're getting out. Wait, let's just figure out. Let's expand that out and make that 2. I don't know if I can find a good example, but if I turn that off, it's now ignored by the blending thing. So it just adds these two and averages them out. So if I put that 2, then it's 1 plus 2, but it's still divided by 3 because there are 3 values coming into the blend operation. And then I turn it on, and now it's 1 plus 2 plus 1. It's 4 divided by 3, which is 1 1/3. However, it also works if you half power them. So if I power that by half, just so you're aware, this sends out, if something is powered, only half powered, it usually sends out like that amount of the value. So it's sending out a 1, but then it's only half powered, so it'll send out half of 1. So it's sending out 0.5 over here. So it's sending out 1, 2, and half, which is 3.5, into here. But then it's dividing it by 3 because there are 3 values. So if I actually lower that one, then you get a nice round number. So 1, 2.5, 2.5. But that is powered by only a half. So this is like half a wire coming in for the blending averaging thing. So you add these up, which is 2.5, but then there are only 2.5 kind of wires coming in.